Hey everyone, in this video we're going to solve a limit problem that looks a bit tricky at first. And this is also a practice problem from AP Calculus BC. Let's break it down step by step. First, intuitively we want to know what's happening when x goes to infinity. So let's take a look. In the numerator, when x goes to infinity, the 6x squared goes to a very large value. Since we have a negative sign in front of it, the numerator tends to go to negative infinity. And in the denominator, we have 5 plus 3e to the x. Since e to the x grows super fast as x goes to infinity, the e to the x part is dominant and tend to go positive infinity. So here we have something like negative infinity over infinity. So a format like that, we need to think a little deeper because it is called an indeterminate form. Means the limit is not decided at the moment. So second step is we want to understand how fast the top and bottom grow. So the key idea here is x squared is a polynomial. And e to the x is an exponential function. Overall speaking, exponential function grows way faster than polynomial. So even though both parts goes to infinity, the bottom tend to grow much more than the top part. Which suggests that the whole fraction should shrink towards zero when you have a very, very large denominator. Okay, intuitively we predicted what should happen. So let's solve it by a more precise definition. There are two methods to do it. The first method is by dividing each term by x to the x, which is the fastest growing part in our function. Okay, now if we look at each piece of the function, this part, as x goes to infinity, goes to 0. This part, as x goes to infinity, also goes to 0. Because we know exponential function grows much faster. And the piece here, 5 over infinity, also goes to 0. So the whole thing becomes 0 over 3, which goes to 0. Similar to our previous prediction. Method 2 is to use L'Hopital's rules if you have learned how to calculate derivative of a function. So the limit of the original function is equal to the derivative of the numerator over the derivative of the denominator. And this is because previously we showed that this function has a form of negative infinity over infinity. So this is a form that we can use L'Hopital's rule. Okay, we take the top derivative, which gives us negative 12x over the bottom. We have 3e to the x. Here we still have negative infinity over infinity, which we can take derivative again. And bottom take derivative again, which we would get negative 12 over 3e to the x. So here, as x goes to infinity, we would have negative 12 over the bottom still goes to infinity, which gives us a really small number. Therefore, the answer is 0, the same as the method above.